Put two people who are both 65 side by side. One climbs a flight of stairs, catches their breath, and keeps talking. The other needs several minutes to recover. Same age on paper, very different age in the body. That difference is the key to understanding aging because your birthday counts years, but your body records damage, repair, adaptation, and reserve. Those records don't move in a straight line. They don't change at the same speed in every tissue, and they're only loosely connected to the number on your driver's license. So the 8 levels in this explanation aren't 8 birthdays, and they aren't a diagnostic scale. They're 8 layers, moving from the smallest instructions inside a cell to the way your whole body functions in real life. If you've ever wondered why one part of you can feel young while another suddenly feels older, this map is exactly where that contradiction starts to make sense. Level 1 is the instruction itself, your DNA. Every cell depends on genetic information that has to be copied, protected, and repaired. Normal metabolism creates stress. Sunlight, tobacco smoke, infections, and other exposures can add more. Most of the time, repair systems handle the damage. Aging begins to show at this level when small errors and injuries accumulate faster than they are corrected. Telomeres belong in this first layer too. They're protective structures at the ends of chromosomes, often compared with the tips on shoelaces. That comparison is useful, but it's incomplete. Telomere shortening is one recognized feature of aging, not a single countdown clock that tells you exactly how long you'll live. No, and one short telomere test can't summarize the condition of an entire person. What matters here is reliability. A younger system usually has more room to absorb errors without losing control. As damage accumulates, cells may repair it, stop dividing, or remove themselves. Those are protective responses. The problem comes when the pressure is repeated across millions of cells and the backup systems have less room to work. Level 2 is the way those instructions are read. Two cells can carry essentially the same DNA and still behave differently because different genes are turned up, turned down, or kept quiet. This layer is called epigenetic regulation. Think of the DNA as a large reference manual and the epigenetic system as the tabs, highlights, and access rules that decide which page gets used. With age, some of those access patterns drift. A cell can still own the correct manual, but become less precise about which instructions belong to its job. That doesn't mean every age-related change is damage. Some changes are adaptation. The useful idea is that biological aging can alter control before an organ looks obviously different. This is why so-called epigenetic clocks are interesting to researchers. They look for patterns in chemical marks associated with aging. But a clock estimate isn't a verdict, and consumer tests don't turn a complex body into one perfectly meaningful number. The science can describe a pattern at the group level more confidently than it can predict one person's future. Level 3 is quality control. Cells constantly build proteins, fold them into working shapes, inspect them, and remove the ones that are damaged. They also recycle worn cellular parts through processes that include autophagy. It is less like spring cleaning and more like maintenance in a busy kitchen. If damaged tools and spoiled ingredients keep piling up, even a good cook eventually loses counter space. The formal term for keeping proteins balanced is proteostasis. Aging can weaken that balance while the recycling system can become less efficient. Misfolded proteins, damaged components, and cellular debris are then harder to manage. This matters especially in long-lived cells, including neurons, because some of them have to maintain themselves for decades. Notice the progression. Level 1 concerned damage to the information. Level 2 concerned access to the information. Level 3 concerns whether the cell can turn those instructions into clean, working parts and clear away the failures. Each layer can strain the next one. Level 4 is the energy budget. Mitochondria help convert fuel into usable energy, but they aren't tiny batteries that simply run down with age. They're responsive structures. They change number, shape, and activity according to demand, nutrition, movement, illness, and stress. The body also uses nutrient-sensing pathways to decide whether conditions favor growth, storage, maintenance, or repair. As those signals become less coordinated, a cell may have fuel available and still handle it poorly. Energy output can become less flexible. Stress signals can rise. Recovery can take longer. In real life, this layer may be felt as less reserve rather than a dramatic failure. The same walk costs more. A bad night carries into the next day, or an illness takes longer to shake. Actually, this is where a popular idea needs trimming. Aging isn't just your metabolism getting slower. Metabolism is part of the picture, but the deeper issue is coordination. Energy production, nutrient sensing, cleanup, and repair all talk to one another. Changing one dial doesn't automatically reset the whole board. Level 5 is the cell that stops but doesn't leave. When a cell is badly stressed or damaged, stopping division can protect the body from passing that damage forward. These stopped cells are often called senescent cells. In the right context, cellular senescence is useful. It helps with processes such as wound responses and can limit dangerous growth. The trouble appears when senescent cells accumulate and remain active in tissue. Some release signals that affect nearby cells and the local immune environment. One cell isn't the story. A neighborhood receiving too many distress messages is. That shift can make inflammation easier to sustain and tissue function harder to coordinate. This is also why the phrase zombie cell is catchy but a little misleading. The cells aren't simply dead cells refusing to disappear. They're living cells in an altered state, and their effects vary with tissue, context, and time. The cartoon is memorable. Biology is messier. Level 6 is the repair reserve. Skin replaces damaged cells. Blood is continuously renewed. Muscle adapts after use. The lining of the gut turns over. Different tissues do this at different speeds, but many depend on stem and progenitor cells that can produce fresh working cells when needed. Over time, that reserve can become smaller or less responsive. Stem cells may face accumulated damage, altered signals, or a tissue environment that no longer supports repair as well as it once did. A cut can close more slowly. Muscle can be harder to rebuild after inactivity. Recovery after infection or surgery may demand more of the system. No, this doesn't mean the body suddenly loses the ability to repair itself at a certain birthday. It means the margin becomes more important. A week in bed at 40 and a week in bed at 80 aren't the same biological event because the older body may have less muscle, less cardiovascular reserve, and a slower path back to baseline. Level 7 is communication across the body. Cells don't age alone. They exchange hormones, immune signals, nerve signals, nutrients, and chemical messages. The gut microbiome participates in that conversation too. With aging, communication can become less precise. Some useful signals weaken, some stress signals linger, and low-grade inflammation can become easier to maintain. Researchers often use the word inflammaging for this chronic inflammatory background. It doesn't mean all inflammation is bad. Acute inflammation is part of defense and repair. The concern is a signal that stays partly switched on after the immediate job is over, like a building alarm that keeps buzzing softly enough to be ignored, but loudly enough to disrupt every conversation in the room. This 7th level connects the earlier ones. Damaged molecules can change cell behavior. Poor cleanup can add stress. Senescent cells can alter local signals. Changes in the microbiome can affect the immune environment. The result isn't one master cause. It's a network that becomes easier to disturb and harder to settle. And now we reach the level most people notice first, even though it comes last in the chain. Level 8 is whole body reserve. This is where molecular and cellular changes become visible as function. How quickly do you recover after climbing stairs? Can you carry groceries, hear a conversation in a noisy room, keep your balance when you turn, learn a new route, and recover after an infection? Aging becomes personally important when capacity narrows and ordinary demands begin using more of the reserve you have left. That is why two people with the same chronological age can look so different in motion. One may have more muscle reserve. Another may have better cardiovascular conditioning, stronger social support, fewer untreated conditions, or an environment that makes activity easier. Genetics matters, but so do disease, behavior, stress, access to care, and the physical world around a person. This final level also explains a strange feature of aging. A body can compensate for a long time. You may not notice a gradual loss while daily life stays below your limit. Then you have an infection or a fall. A medication changes or several inactive weeks push demand above the remaining reserve. What feels sudden may be a threshold crossing after a long, uneven process. Take a breath here because this is the most useful part. The 8 levels are connected, but they aren't a staircase that only goes down. The body keeps adapting. Healthy behaviors don't erase every hallmark of aging, and no routine makes a person biologically 20 again. They can still protect capacity, reduce the burden of chronic disease, and give repair systems a better environment in which to work. Regular physical activity is one of the clearest examples because it asks muscle, heart, lungs, balance, and energy systems to keep responding. A balanced diet supports the raw materials those systems use. Avoiding tobacco removes a major source of repeated injury. Sleep, preventive care, hearing and vision support, vaccination, and social connection can matter for different parts of the same reserve. The practical move isn't to buy a biological age score and chase it every morning. Watch trends in function. Is the usual walk becoming harder? Are you taking longer to recover from normal effort? Has balance changed? Are fatigue, weight loss, weakness, memory problems, or shortness of breath new or persistent? Those patterns are worth discussing with a qualified health professional, especially when a change is sudden, severe, or keeps returning. And don't use this map to diagnose yourself. Use it to ask a better question. Instead of asking, "How old am?" ask, "Where is my reserve changing, and what information would help me understand why?" That question brings us back to the two 65-year-olds on the stairs. Their birth certificates tell you how long they have been alive. Their recovery tells you how much demand their bodies can currently absorb. Remember this: aging isn't one clock. It's 8 connected layers of repair and reserve. Which level would you want explained next in a full video? Cellular cleanup, mitochondria, senescent cells, inflammation, or whole body reserve?